Imagine manufacturing a shaft that is just 0.02 millimeters oversized. The machine fits perfectly, but the bearing fails. Why? Wrong measurement tool or wrong least count. Hello everyone, welcome back to SimpleGAN. Today's video is a must-watch masterclass where we will cover all common mechanical measuring tools, their working principle, their least count, and where exactly they are used in industry. By the end of this video, you'll never confuse vernier, micrometer, dial gauge, or comparator again. Let's begin. Before tools, let's understand least count. Least count equals the smallest value that a measuring instrument can measure accurately. Smaller least count means higher accuracy. For example, a steel rule has a least count of 1 millimeter, while a micrometer has a least count of 0.01 millimeter. Now, let's explore linear measuring tools. First, the steel rule. It has a measurement range of 0 to 150 millimeters or 0 to 300 millimeters, with a least count of 1 millimeter. Steel rules are used for rough measurements, layout marking, and fabrication work, offering low accuracy but high speed. Next, the vernier caliper. It typically has a measurement range of 0 to 150 millimeters or 0 to 300 millimeters. The least count is 0.02 millimeters for metric versions and 0.01 millimeter for digital versions. Vernier calipers are used for external and internal diameter, step, and depth measurements, making them the most commonly used tool in workshops. The vernier height gauge has a measurement range of up to 300 millimeters and a least count of 0.02 millimeters. It is primarily used for vertical measurements, marking layout lines and inspection tables. Finally, the vernier depth gauge, with a least count of 0.02 millimeters. This tool is used for measuring groove depth, hole depth, and slot depth. Moving on to precision measuring tools. Let's start with the outside micrometer. It comes in ranges like 0 to 25 millimeters, 25 to 50 millimeters, and so on, with a least count of 0.01 millimeter. Outside micrometers are essential for measuring shaft diameter, thickness, and other high-precision jobs. The inside micrometer also has a least count of 0.01 millimeter. It is specifically designed for bore diameter and internal precision measurements. The depth micrometer, with its 0.01 millimeter least count, is used for keyway depth and counterbore depth. Now, let's delve into comparative measuring tools, starting with the dial indicator, also known as a dial gauge. Standard dial indicators have a least count of 0.01 millimeter, while precision ones can measure down to 0.001 millimeter. They are widely used for runout checking, flatness, alignment, and eccentricity, especially in machine alignment. The dial bore gauge has a least count of 0.01 millimeter or 0.001 millimeter. It's used for bore size comparison, as well as taper and ovality checking. Finally, comparators, which can be mechanical, optical, or pneumatic, boast a least count of 0.001 millimeter or better. Comparators are crucial for mass inspection and production quality control. Let's move on to angular measuring tools. First, the protractor. It has a least count of 1 degree and is used for general angle measurement and fabrication work. The Vernier Bevel protractor offers a higher precision with a least count of 5 minutes. It's used for precise tool angles and other precision angular measurements. The sine bar, with an accuracy of up to 0.01 millimeter, is used for precision angle setting with slip gauges. Now, let's look at gauges, specifically GO/and OGO gauges. Starting with the feeler gauge. It has a least count of 0.01 millimeter and is used for clearance measurement, valve tappet setting, and bearing clearance. The screw pitch gauge, with a least count depending on the pitch set, is used for thread pitch identification. The radius gauge, with standard radius steps, is used for checking fillet and corner radius. Plug gauges, with micron-level accuracy, are used for hole inspection, specifically go/no-go checks. Similarly, snap gauges, also with micron-level accuracy, are used for shaft inspection. Finally, let's cover surface and special measurement tools. The surface roughness tester. It has a least count of 0.01 micrometer and is used for surface finish measurement. The thickness gauge, with a least count of 0.01 millimeter, is used for measuring sheet metal, plastic, and rubber parts. Here's a quick summary table. Steel rule, 1 millimeter. Vernier caliper, 0.02 millimeters. Micrometer, 0.01 millimeter. Dial gauge, 0.01 or 0.001 millimeter. Bevel protractor, 5 minutes. Feeler gauge, 0.01 millimeter. Comparator, 0.001 millimeter. Now for a practical tip. Which tool to use? For rough work, use a steel rule. For general workshop tasks, a vernier caliper. For high precision, a micrometer. For alignment and runout, a dial gauge. For mass inspection, gauges and comparators. Remember one golden rule. Wrong tool equals wrong measurement equals failed component. If accuracy matters, least count matters. If this video helped you, please like the video, share with your engineering friends, and subscribe to Simple GAN for practical engineering knowledge. Comment below, which measuring tool do you use most in your workshop?